Alright, I'm off testing in Abilene, enjoying computer science and trying to wonder why I did this to my brain. But you're enjoying math. So let's talk about today rotations. We've talked about other transformations. We discussed translations where you're moving a figure always left or right and then up and down. Next we talked about reflections, which is where you're reflecting. Algebraically, when you reflect across the x-axis, the y-coordinate becomes negative. And if you reflect across the y-axis, the x-coordinate becomes negative. So let's look at rotations. We're going to look at all three methods again, just like we've done. So first of all, a rotation is a transformation that turns a figure around a given point called the center of rotation. Now, for all our exercises, the center of rotation is going to be the origin, or 0, 0. So the image has the same size. This is the image, remember it's got no apostrophes, has the same size and shape as the pre-image. That's right there. So the pre-image has apostrophes. So we can see our image here is a triangle, here it's a triangle, same size, same shape. What's changed is its orientation, how it's facing. So stop and write down those notes. Alright. So hopefully you wrote those notes and didn't just move on. So to rotate a figure in coordinate plane, you rotate each of the vertices and then connect them to the image. So there's a couple ways to do this. Probably the easiest is the Pati Paper, and I've already happily done my Pati Paper, so you won't have to watch me do this on the video. So in the Pati Paper, I'm going to take and make sure I make a very good XY axis. If your XY axis is sloppy, then all your other points are sloppy. So here's a little interesting trick. Now I drew this on Pati Paper and I put it here. Go on the back side and redraw over the back of your dots. What you did was you're putting graphite on the back side of those dots. So you're turning it into graph paper, or not graph paper, I can't even think about what it is, carbon paper. So when I rotate it, it says I'm going to rotate it, and I'm going to rotate it 90 degrees clockwise, which means I'm going to take it and rotate it exactly 1 vertices. Now, I made carbon on the back of these, so all I got to do is color the front again. And you'll notice when I lift it up, it transferred my dots to the bottom paper. So I didn't even have to guess, it transferred part of that for me. So it rotated, and all I'd have to do now is connect the dots, and I get my image, because it started out with a pre-image, right? Please use straight edges. Don't make sloppy lines. If you make sloppy lines, then I have to guess whether or not you actually made a line. So using this Pati Paper makes your life easy. Can you do it? And the back side, if you cover those dots, it makes the transfer very easy. I did use my whole Pati Paper for this and made a large graph, but you guys can do these graphs in corners. I have lots of Pati Paper, but let's not waste it, okay? Alright, so there's another way you can do this, and you can do it algebraically. Algebraically means you can take each of those points and modify them. So if you're going clockwise 90 degrees, what you're going to do is you start with an x and y. The x coordinate is going to become negative, and it's going to swap places. So when you end up, your new coordinates will be the old y and the negative old x, and they become the new x and y. So these become your new x and y. When you counterclockwise, we're going to do the exact opposite. We're going to leave the x alone, but we're going to make the y negative, and then we're going to flip them. So your old y becomes negative, and it's now the new x, and your old x just stays the same as the new y. Now, 180 degrees clockwise, life is pretty easy. We just multiply both coordinates by -1 and make them both negative, the opposites, and they stay in the same place. So life's pretty good. 180 degrees, and it doesn't matter if they say 180 degrees clockwise. It doesn't mean anything different than 180 degrees counterclockwise, because you're going exactly half away. So let's do a little practice on this. I've got this graph paper. I'm going to use the same Pati Paper I used before. I'm just going to rotate it a little bit so that I got a new spot. I'm going to draw out my dots. So this one I'm not using. I'm going to draw out my dots. I'm going to draw my lines. Straight edge, please. Okay, So I got it. I'm going to make sure I write down my coordinates. That way when I move them, I'll get the same coordinates. Okay, A is always going to stay there. So it says I'm going to graph it after a 180 degree rotation, which means it's going to come all the way over here. Now, I'm going to make my life easier. I'm going to darken the back side so that when I graph it, I can just write down my dot and it'll take it. So here I'm moving 180 degrees, and it doesn't matter which way we go. So I'm going to go, there's 90, there's 180. So once I go 180, I'm going to just draw my dots. The A doesn't stay the same, or stays the same. And you'll notice I have light dots here. So now all I got to do is cover them over. I got to make sure I look down here and make sure I label my dots. So this dot was B, and it's now apostrophe. This dot was C, and it's now apostrophe. D, it's now apostrophe. And this is A, and it's also A apostrophe. So they're not connected. That was pretty easy to do a 180 degree rotation, right? The next thing is pretty common test-wise. Making you move an entire figure test-wise is difficult because it means somebody has to grade your ability to move a figure. A lot of times they'll just have you move one point. And this one's just saying point C. So we're going to move point C 90 degrees counterclockwise, and then we're going to do it 180 degrees rotation. So 90 degrees counterclockwise. We're going to use algebra for this. So point C, we're going to get the coordinates for point C, and right now it's 1, 2, 3, 4x. X is 4, and y is 1, 2. So counterclockwise, we're going to swip the coordinates, and the y is going to become negative. So what we're looking for, the new C will become negative 2. I moved the y to the front and made it negative, comma 4. So I go over here, negative 2, comma 4. And there's the new C. And I have to make it C double apostrophe because there's already a C apostrophe, right? So that is negative 2, comma 4. And it says rotate another 180 degrees. So rotate 180 degrees, I leave the coordinates where they're at, but I multiply both by negative 1. So my new C is going to be 2, comma, negative 4. So 2, comma, negative 1, 2, 3, 4, negative 4. And there's my new C, which is C triple apostrophe, and it's 2, comma, negative 4. And you'll see it's exactly the opposite coordinate. So yeah, and one of those ways to test it, 180 degree rotation, you can draw a line through the same points, and it goes through the origin. Well, if my graph was a little better, it would go through the origin. All right. So I hope that helps. Use the method that works best. I do like the Pati Paper. It makes life pretty easy. But for a single point, doing the math, and I could have done the math all over here without plotting it and just got my final point and had no problem at all. So I hope that helps. Write the notes. Your notes are being graded.